This demonstration shows a scaling of OpenContrail virtual networking system and the Neutron plugin for OpenContrail. So here I have 1000 compute nodes. These are managed by 3 bare metal OpenContrail controllers and 1 bare metal OpenStack. There are these 3 controllers. Around 700 compute nodes are connected to each controller, and each compute node take 2 controllers. If you see the virtual routers, here the green bubbles mean that virtual machines are present on those virtual routers, and the blue bubbles means that no virtual machines are scheduled on these virtual routers. So I have actually spawned around 6 to 5 VMs on each of the virtual routers. All this UI comes using the analytics database that OpenContrail has, and there are 3 analytics nodes. There are 3 compute nodes. Each compute node also has its corresponding Neutron server. So there are 3 Neutron servers. All the Neutron APIs are load balanced between the 3 Neutron servers. So how was this setup achieved? So we have the controllers on the bare metal servers, but the V routers are virtual machines on another control setup. So this is the underlay control setup. So we have around 101 bare metal compute nodes, and here also we have 3 bare metal servers representing controllers and 1 bare metal server for OpenStack. You can see the 3 controllers each with around 70 VMs. We have these V routers. On some of them we have 5, some of them we have 19 V routers. So here the analytics engine is collecting the data of all the OpenStack communication that is happening on the overlay, and there are 3 config nodes with Neutron in each one of them. So let's go back to the system that we want to demonstrate with 1000 V routers. So on this one, in the networking tab, we can see that I have actually created around 55 projects, and each of the project has around 5 networks, and then each of the networks has around 20 to 30 virtual machine. So if you go to the dashboard, so there are around 5300 instances. So now the demonstration is about, we'll take one project. So let's take demo 1, and then this is the topology. So we have 5 virtual networks: VN1, VN2, VN0, VN4 and VN3, and these are connected by a Neutron router, and each one of them has around 80 to 60 instances. So totally there are 320 instances in this project. So I have a security group rules, a default security group, such that in ingress I allow all traffic from the default security group, and the egress I allow only for those 5 networks that we have. So we have 192.68.0, 1, 2, 3 and 4. So I chose randomly 2 different virtual machines in this project. So let's see what the IP address for this is. So it has 1 dot, so it belongs to VN1. So what I'm going to do is I'm going to ping 192.168.2.21. So it is actually pinging via virtual network 2. Now I'll choose another of the virtual machine. Let's see what the IP address for this guy is, and it is 1.61. So I'm going to ping 192.168.3.16. So on this virtual machine we are pinging network 3. On this virtual machine we are pinging network 2. Now let's go back to the managed securities rule. So we are from 1 we are pinging 2, and from 1 we are pinging 3. So let's take the network 2 and delete that rule. The rule is deleted. Now instantly we should see that the ping is stopped for network 2 and ping is still going on for network 3. Now we go back to the managed security and add back the rule. So I say other protocol egress and 192.168. We had deleted to 24. So I have added that rule and let's see if the ping started. Yes, this ping has started, and all this while the ping for the other network 3 was not affected at all. So this is a demonstration to show that the information that we are giving to the Neutron is propagated through this OpenContrail system to all the compute nodes, and it is affected immediately. Another thing is that while one rule is changed, only the flows for that particular rule get affected, the other flows don't get affected. So this is done in a scalable manner, and this shows the scaling of OpenContrail networking. Now let's go and see the underlay. Now just to show that how the system is behaving, we'll go and show the network in which I have spawned is 1000 way routers. So the 1000 way routers have been spawned on IP fabric network. So let me go to the IP fabric network. So this is all the traffic that is going through this network, and most of this traffic is the Openstack IPCs and the OpenContrail IPC protocol traffic between all the 1000 compute nodes and the controllers. Since the controllers are on the bare metal, this traffic only represents the traffic between the controller and the compute nodes, because the compute nodes as a VMs. It's around 1.9 megabytes for the entire system to work. Now let's see what kinds of applications are using what traffic. So this is a port map in this system. So let's only take destination ports. So most of the ports here are ephemeral ports, so we don't care about this. The ports in the less than 10,000 range are the ones that we care. So the size of the bubble represents the number of connections that this particular port range was using, and as the port is going higher, as the bubble is going higher, the bandwidth used is more. So we have this low bandwidth, very high connection bubble here. So this is all DNS to the port 53. There are many connections every time something is getting resolved. Now these are the 4 bubbles that are most useful. So let's see what this bubble is. So this is between 7936 and 81. So let's see what it is. So 8093 is the port used by our analytics engine. So maximum traffic that is used in this application is by the analytics engine. Now there are 3 in this region. So this is port number 5672. So this is the RabbitMQ port that is used in the system, and these are all the compute nodes that are talking to the OpenStack controller using the RabbitMQ. So this is all OpenStack traffic. Now let's see, this was analytics, this was RabbitMQ. Let's see what these 2 guys are. So this thing is port number 5269. This is the XMPP protocol. This is the traffic between the OpenContrail controller and 1000 compute nodes that we have. It's a very less bandwidth, around 800 kbps. And the traffic here is 5992. This is a discovery service within the OpenContrail system, so which is also very low, which is around 300. So you can see that even from the system point of view, the OpenContrail controller is actually quite less overhead. In fact, here you can see that the RabbitMQ is actually using more traffic. Well, the RabbitMQ is using 32 megabyte and the OpenContrail control traffic is around 800. So this shows that how scalable the system is. And the analytics is collecting all the flows in the system and giving you all this visibility, and it is using around 100 megabytes for 1000 compute nodes.